Hello everyone. These are few questions related to FPGA and ASIC. The first one is, what is a FPGA? FPGA is an IC or integrated circuit. An FPGA is called Field Programmable Gate Array. Why it is used? FPGA is mostly used for prototyping. And what is a prototyping? Let me explain you with an example. Let's say you want to design a filter, FIR filter, a digital FIR filter, and you want a IC for that one. That means FIR filter IC. For that, first what you will be doing, as it is a digital circuit, so first what you will be doing, you write a Verilog code. Then that Verilog code is sent to fab. Directly Verilog code is not sent to fab, but the GDS2 file. The GDS2 file is sent to fab. Then you get the hardware, and once the hardware comes, then you test that one. And you check whether the hardware that you got is as per the specification or not. That means the way or the functionality, what is the functionality of FIR filter, that functionality you are getting or not. So this is one way, right? And what will happen if this hardware, whatever hardware you got from the fab, that comes faulty, then that hardware cannot be used. So all these hardware are now wasted, right? So what is done in the industry is, before the coding files, and that is GDS2 file, not exactly Verilog code, but that is called GDS2 file. Once before the GDS2 file is sent to fab, that code, the code that you have written, the Verilog code, is tested again and again to check the functionality of your required logic. And how they check that one? They use FPGA. So to check the functionality of your design, or verifying the functionality and the performance of your design, what they do, they port your RTL or Verilog code, or they dump your code into FPGA, and they check it, they test it. And if they find any error or any mistake, then they rectify it. Then again they write the Verilog code, then again they test it using the FPGA board. And once everything is done, then at the end of this VLSI design cycle, they generate GDS2 file, and that file is sent to fab, and from the fab we get the hardware. So this porting your RTL or Verilog code to FPGA to test the functionality of your design before it is sent to fab is called prototyping. So basically prototyping is nothing but verifying the functionality of your design before the real hardware comes from the fab. And if at any point, if any error comes, or any error or any mistake arises, that is rectified. Okay. Then the next one is, the next question is, what is inside an FPGA board? Inside an FPGA board, three things you will find. The first one is logic blocks, the second one is programmable interconnect, and the third one is IO blocks. See, you are porting RTL code to FPGA board, and you are writing RTL code for your digital logic. And digital logic can be combinational or can be sequential. So there should be some kind of logic inside FPGA to test your RTL, and that is either combinational or sequential design. So that part is called your logic blocks. So inside FPGA, one part is this logic blocks is used to implement combinational and sequential logic. The second one is programmable interconnect. Let's say you have three number of module, three number of logic blocks. Now you want to connect, now you want to interconnect, and for that interconnection, what is inside FPGA is called programmable interconnect. So through this programmable interconnect, this is nothing but a wire. It connects the input and outputs of the logic blocks. The third part is IO blocks. You have a FPGA board. Now you want to connect one memory module from external source. Okay, so externally you want to connect one memory module or Wi-Fi module, then that is done by this IO blocks. So it is for this IO blocks is for external connection. Okay, so logic blocks, programmable interconnect, and IO blocks. The next one is the difference between FPGA and ASIC. See, both are IC. Okay, the first difference is FPGA is used for prototyping, but ASIC is not used for prototyping. The second one is FPGA, if the production number of product, you want to design a product for smaller number, then FPGA is preferred. If more products you want or you want large production, then you go with ASIC. Third one is frequency of operation is less in case of FPGA and frequency of operation is more in case of ASIC. It consumes more power. FPGA consumes more power, but ASIC consumes less power. And ASIC, in case of ASIC, it better utilizes your area. Okay. The next one is on what basis FPGAs are used for different application. So FPGAs are used based on these 4 points. So you choose FPGA or someone choose FPGA as per their requirement. Okay, and this requirement depends on this one. The first one is how many number of logic blocks are there in an FPGA, how many number of IO blocks are there in an FPGA, how many number of block RAMs are there in an FPGA, how many number of MAC blocks are there in an FPGA. Okay, so if your requirement is more number of logic blocks, then if it is a bigger project or bigger circuit that you want to implement, then you go with FPGA having more number of logic blocks. If you want many number of external device to connect your FPGA, then you go with FPGA having more number of IO blocks. If you want more memory, then you go with FPGA having more block RAM. This MAC block is multiplication and accumulation, that is for DSP application. The multiplication and addition, there is a block that is called MAC block, and if your application is related to DSP, then you can go with FPGA having more number of MAC block. Okay, so what are the technology that is used to design FPGA? This is another question. What are the technology that is used to design FPGA? If FPGA is programmed permanently, then flash and anti-fuse technology is used. And if FPGA can be reconfigured, means you want to change your design later also, then SRAM technology is used. So based on the requirement, if the requirement is permanently programming, then flash and anti-fuse technology is used. And if the requirement is reconfigurable one, means you can change your design at later stage, then SRAM technology is used to design FPGA. Advantage of FPGA over ASIC is this. First, the basic advantage of FPGA over ASIC is ability to reconfigurable to fix bugs. Means FPGA is used for prototyping. Means easily you can fix the bugs. If you find bugs, then you can easily, because you are writing the code and you are porting that one to FPGA. So at some point, if you find bugs or error, then you can easily change your program, right? Your Verilog code. That is what it is. Ability to reconfigurable to fix bugs very easily. This is the common advantage or the basic advantage of FPGA over ASIC. The second one is shorter time to market. FPGA is shorter time to market because ASIC is a very long process, like fabricating the hardware or fabricating the IC. So The FPGA design is shorter time to market. And the third one is low cost. If you want to design an FPGA, then the cost is less than designing ASIC, okay, at large scale. So these were few questions related to FPGA and ASIC. In my next tutorial, we'll see some more questions and answer. Okay, so thank you so much for watching this tutorial.